All right, it's recording. Okay. First of all, there's a website presentation showing more details about this generator. Mostly, the most interesting thing there is just photographs of taken during its construction, so you can get an idea of the way the core is constructed using bar magnets. Right, so magnetic core propeller generator.blogspot.com. So just to illustrate how the way in which this magnetic core of the generator would be rotated by using these electromagnets creating a rotating magnetic field. If you've got a bar magnet here mounted on an axle with its north pole there, capable of rotating in the horizontal plane, north pole there, south pole there. If you set these electromagnets to be polarized north, south, south, north like that, the bar magnet will be repelled to and attracted at the same from the north pole at 1 here and attracted to the south pole here. Its momentum will carry it through. The same thing is happening at the opposite side. The south pole of the magnet is repelled by that electromagnet there, attracted to that. However, when it gets to this position here, it will stall, being attracted at once to these two south poles, unless the polarity in this magnet and this magnet, electromagnet, are switched. So that's the general idea. So having switched this polarity so that this then repels while this is attracting, the same thing will occur when the permanent magnet gets to the opposite position, at which time these same two the polarities have to be switched again. So for this pair, 2 and 4, those polarities have to be switched at every 180 degrees of rotation, right? So having first of all switched this one at 2 to allow it to reach this electromagnet pole at 3, that pole and the opposite, the polarities in those have to be switched, right? Which will then repel. So this will have switched from south to north. The north is there, and that will repel to there. So you can see that there's two. In order to get this magnet to continue to rotate, first of all, this pair, the polarity has to switch. 90 degrees later, the other pair has to switch, and those polarities of those pairs have to remain that way for 180 degrees. So you've got two pairs, 90 degrees out of rotation cycle, out of phase, switching their polarities. All right, so those two, this is just illustrating what occurs in the horizontal plane. In this generator, the core is constructed of, the core is a 3-dimensional stack in a helix. So there are 12 electromagnets, so there'll be 3 of these pairs, not just one pair. So six electromagnets which have to wide in parallel to the battery, have to switch their polarities every 180 degrees, and similarly the other pair 90 degrees, the other 3 pairs. Right, so the second thing that I wanted to talk about here is to do with the structure of the core. Now, if we take a sphere here and we begin at the diameter, if we imagine that permanent magnet which we're spinning to represent the diameter of a sphere like that, then just considering the sphere, if we take a point here and rotate 1 degree of longitude at the same time as elevating 1 degree of latitude, and continue to do that, you'll have a curve on the surface of a sphere, which I'm calling a spherohelix, like that, which so with the angle of rotation equal to the angle of elevation. So every point on that curve that will be described in that way. So that curve will have the same length as any of the great circles of the sphere. Further, if you look at that particular curve, if you look at that curve from as a two-dimensional curve in the plane tangential to this point and perpendicular to the diameter there, the curve will be a function. The components, the lateral components along here, will be a function of twice the sine of twice the angle of rotation or elevation. Right? That's because any of the radial components to the curve from the axis of the sphere are a function of the cosine, the radius times the cosine of the angle, and then that will form the hypotenuse of the triangle where in the horizontal plane at any level, so that the lateral component there will be a product of the sine and the cosine of that angle. So this curve, looking at it that way, will be those vertical components in that case, looking that way, will be a function of half times the sine of twice the angle. All right, and similarly, looking perpendicularly, looking along the other diameter at 90 degrees to that, the curve will look like a function of the cosine squared. Looking from the top, you have that curve on the surface of a sphere will look like two circles of half the radius of the larger circle of the sphere. All right, that's the geometry of it. So this side, if you look at this if you look at the photographs at this site, you'll see that the core is constructed using a spherical wooden a wooden sphere with slots in it, so that the permanent magnets are inserted into the slots, so that they form this spherohelix. So this diameter, that will be a permanent magnet like this one here across there. And as we rotate up, the magnets get smaller and smaller and smaller up to the 0 point here. So one side of this curve is the north side, and the other side is the south side of this magnetic core. Right? So that's the structure of the core that we're trying to rotate using a rotating magnetic field in these electromagnets powered by a 12-volt battery. That's the basis of it, right? So if we can get these polarities to switch, as I've shown, this core we should be able to get that to rotate continuously. The aim of which is to determine the nature of the current produced in the winding around that. And I'll get to the winding in a minute, or at another time perhaps. So the wooden sphere that houses these magnets, in any properly built apparatus, you would use some very light, strong insulator to house that core. The winding will be wrapped around that in a particular way, which I'll show you. Now, can we turn off this Mandy? Mandy? Oop. How do I turn that off? Because I finished with this little bit here.
Okay.
I think.